Okay, welcome back again. We are going to carry on with analyzing capacitors. We're collecting more data because the data we had last time was lovely. You made a very nice graph with a very nice line of best fit. And I'll be asking you later on in this lesson what you've reflected on that graph. But for now, we're going to collect some more data. So last time we discharged a capacitor through a resistor. Today, we're going to charge a capacitor through a resistor. If you remember last time, I just connected the capacitor straight to the power pack, which I shouldn't really do, really. I should charge it slowly, but for brevity, we just connected it straight to the power pack and it charged practically instantly. Today, we're going to charge it a little bit more slowly. So we've got the power pack again, and I've left it set at the same 6 volts or so that it was at last time. Doesn't really matter. And this time the resistor is in the charging circuit. So as the current flows, it'll be restricted a little bit by this resistor, which will mean that the capacitor does charge over a period of time rather than very quickly. You can see, I guess, that at the beginning, when this thing is uncharged, this potential difference will be 0. And eventually, if we wait long enough, it would eventually come up to the potential difference of the charging power supply. We're going to wait 300 seconds again. I don't think that'll be enough time to bring it quite up to the full 6 volts, but that doesn't matter. It'll be good enough. Okay, so you need to copy that down into your book if you haven't done so already. And then, but you can perhaps do that later because now I just need to make sure that you're ready for the practical like you were last time. So if you could please make sure that you have an empty table of results waiting with the times in it. And again, I would suggest you go up in 5s all the way up to 300, but you will find, like you did last time, that it slows down a little bit towards the end. So you might want to just skip every other line towards the end and just go up in 10s. Same as before, I'll tell you when to start. You're going to need your own stopwatch that you can press go on, and then you can fill this in as we go. I'll run the experiment for 5.5 minutes or so. So if you don't want to start immediately, actually, it would be better if you started immediately today because we all need a common 0. So yeah, I'll say go and you all press start at the same time. And then this is being recorded. So if anything goes horribly wrong, I'll upload it to Classroom and you can watch it back again and strip the results off it that way if you need to. If at any point you're waiting, you need to get yourself a piece of graph paper. So print one of them off again. I've attached it to this morning's post so that you've got something to print, or pull up Excel or Sheets and make it electronically if you know how to do that. Remember, you need to insert a scatter graph, not a line graph. Okay, I'm just going to shut up for 1 minute, make sure you've got a table of results, and then we'll do the experiment. Okay, let's switch to the other camera. Okay, so on the desk in front of you, you can see the circuit. If you trace it out with the red wires, you can see we've just got the series circuit through the capacitor and the resistor. And with the black wires, we've just got the voltmeter attached to the capacitor itself. Power pack's set on around about 6 volts, doesn't really matter exactly what it is. And we're just going to hit the start button, and you hit start on your stopwatch, and this thing will start counting up. So you can fill in already that the starting value is 0. Let me just zoom in on that voltmeter a little bit so that you have got a good view. Okay, so I'll count down 3, 2, 1, and then I'll say go, and I'll flip the switch as I say the word go. Okay, here we go. That's not the go. Okay, 3, 2, 1, go. Okay, 5 minutes is up. So what I'm going to do now is I am going to pause the lesson for half an hour, and you need to get yourself a graph drawn. And then if we could restart this lesson at 10 to, please, at 9:50, and we'll discuss what shape graph you've got and what conclusions you got from either this graph or last lesson's graph. So back here at 10 to, please. You can stay in the meet if you want to.